And I'm going to get as well. People in the meeting. Okay, respiratory system. Well, we went through the digestive system the last month, or in December and beginning of January, digestive system. And remember that this digestive system had an important mission. What was the mission of the digestive system, Adrián? Digestive system was going to do one important process, that is, ¿qué hacía? Digestive system. All these organs that we've studied. Adrián. Bueno, anyone with a microphone that wants to help Adrián? What was the mission of digestive system? Digestion, okay. And we gave a definition for digestion that was transforming food into simple components that are known as nutrients. Okay, so after getting those nutrients, we absorb them and they will go into the bloodstream until they arrive in my cells. A very important organelle in the cell that was going to receive those nutrients was mitochondria, that wanted to do, what's the name of the process that happens in mitochondria and give me energy? Name of the process is Maria, Esther, name of the process that happens in mitochondria. Any other volunteer that knows the name of the process? Cellular respiration, perfect. Well, this cellular respiration happens in mitochondria as long as I have glucose, so those nutrients, and oxygen. So here is where the second system comes, respiratory system. What is the mission of this respiratory system? It's going to get this oxygen for my mitochondria. So oxygen will enter the body and then will go to the bloodstream. Once I have this oxygen in the bloodstream, it will be received by every mitochondria in my body, and I could do cellular respiration. But in this process, I'm going to produce carbon dioxide. So this carbon dioxide will be expelled through the same system. So if I ask you, what's the mission of the digestive system? Get the nutrients that the cells need in order to grow or produce energy. What is the mission of the respiratory system? Get the oxygen that the cells need in order to perform cellular respiration and send out the carbon dioxide they produce. That is going to be the main mission of the respiratory system. What are the components of this respiratory system? Well, we've got all of them here. The respiratory tract, the tube, sometimes we refer to it as the windpipe, la tubería del viento, the windpipe. That is the way we refer to the respiratory tract that contains all these parts. Well, from all these parts that you've got in the picture, I marked these 7 parts that you've got are those the same parts that you've got in your book. Okay, so if you go to your book, page number 44, you're going to see that the first part that the air is going to enter is the nasal cavity. The nasal cavity is connected to the outside through the nostrils. Okay, the holes are the nostrils. So I've got the nose, the structure, the nostrils, and then the air passes to this nasal cavity. Why is it better to breathe using your nose than using your mouth? Carmen, do you know what's the benefit on using your nose instead of your mouth to breathe? If you've got a microphone, you can turn it on. If you don't, just write it down, Carmen. benefits of breathing through nose, or maybe differences. Do you feel any difference when you breathe through your mouth, which is possible? Is there any difference? How do you feel the air when it gets here if you're breathing using your mouth? Anyone that wants to help? Carmen? Your nose cleans the air. Okay, that's one very important thing, that the air that enters your lungs is going to be cleaner if it goes through your nose. Especially thanks to the mucous membrane. But apart from the mucus that your internal cavity of the nose is producing, what else happens in your nose that is better for all the respiratory system? You clean the air. Do you feel any difference when you breathe? When it's very cold outside and you breathe using your nose, how do you feel the air inside? Very, very cold. But if you use your nose to breathe, it's going to be warmer. The nose is going to clean the air, is going to retain dust particles, and dirtiness is going to be retained thanks to tiny hairs in your nose, thanks to the mucus. But your nose will also warm up the air, which is very important because very cold air could damage your lungs. So it's important that is warm this air, and you're going to do the exchange better when the air is warm. Okay, so it's important that you clean it, that you warm it, and it's going to do a third thing, this nasal cavity. It's going to moisten the air. Does anyone know what's the Spanish for moisten? What is moisture? Moisten. Air is going to be, yes, humid. Okay, it turns it into something humid. Humedecer. Okay, so in this first stage, in the nasal cavity, important things are going to happen. Sorry. This nasal cavity is going to filter the air, is going to warm up the air, and is going to moisten this air. So it's going to be easier for your lungs to work, especially for the last part of your lungs, which are the alveoli. We'll see later. So we've got two nasal cavities connected to the outside with the nostrils that are the opening of this cavity, and they contain a mucous membrane. Apart from this mucous membrane, there's another important structure here, the turbinate here. We've got three. In Spanish, we call them los cornetes. ¿Os suenan los cornetes? Bueno, they contain a lot of blood vessels. Those blood vessels are going to be responsible for warming up and moisten this air. So if air doesn't pass through this nasal cavity, but it enters directly through your mouth, it's not going to go through these turbinates, so it will not be so warm and so humid, and it could be dangerous for your lungs, or at least you're not going to absorb so much oxygen. Okay, so this is the first part, the nasal cavity. Then from the nasal cavity, momento que me dicen aquí alguna cosa. Sarah, what's the meaning of moisten? Moisten es húmedo, ¿vale? Not wet, que sería mojado. Moisten es húmedo. Humedecer es moisten. Moistened es húmedo. Okay, you've got it in your book. It ends up with ID. You've got it in your book in page number 44. Air enters the nose and continues through these passages when it is moistened and warmed. Okay, that is the emission of these parts. Okay, then from this nasal cavity, air will enter the pharynx. We said in previous unit that this pharynx, was also part of the digestive system. Remember, that's the mouth with the tongue, and food will go from the mouth to the pharynx. So this pharynx is a common part. It's both for respiratory and digestive system. And at the end of the pharynx, beginning of this windpipe, we had this structure. Does anyone know what's the name of this cartilaginous structure that is at the beginning of this windpipe, separating the windpipe from the esophagus? What was the name of this cartilaginous structure that we had there? Is the epiglottis, okay, double T, but it's okay. This structure was preventing, remember, the air from getting into, the food from getting into this digestive, food from getting into the respiratory tract. The digestive tube is going to go on the back, closer to the backbone, okay, that's the backbone. This is the esophagus, and the windpipe goes on the front. Well, if we go from this pharynx down into the air passage, the windpipe, after finding this top tab, we're going to find this larynx, which is the first part. Well, as you can see here, this larynx is a little bit wider and is the part that when you speak, it moves, it vibrates. It vibrates due to this structure. I'm not sure whether you can see it there, but you've got it a little bit bigger here. What is this structure? They are the vocal cords. And we've got here a picture representing what you see if you take a camera. Sometimes when you go to the doctor because you've got problems with your vocal cords, they take a camera, they introduce this camera through your nose and are going to see your vocal cords. Okay, the doctor is going to see with this camera your vocal cords, and it's going to see something similar to that, this picture. Okay, in this picture we've got this structure that is the epiglottis, so it's this structure here that is the epiglottis. This would be the back. Okay, so we've got down there, that would be the backbone. This is the frontal part, that is the back. We've got the epiglottis here, which is this structure, and then there, this white structure there is your vocal cords. So when you're pronouncing a vowel like E, okay, is your vocal cords will be in this position. While when you're pronouncing an open vowel like A, when you're saying that's the position of your vocal cords. When they are open, they produce a lower sound, and if you close them, they vibrate in a different position, they produce these closed vowels. Okay, so vocal cords are not like the chords of a guitar. That is something that you probably think of. Well, vocal cords are these two membranous structure. They're quite hard, and depending on their tension, they're going to produce one type of sound or a different one. So it's more similar to the opening of a balloon. Okay, have you ever played with a balloon that you fill it with air, and depending on how much you stretch the opening of the balloon, you produce a different sound? That's more or less the way your vocal cords work. Okay, and the vocal cords are inside this structure that is the larynx. You're going to see it better in the following picture. In this picture, what we've got here, that is the larynx protecting the vocal cords inside, and from the larynx, remember this larynx is wider, especially in boys, in male, that is making the sound of their voice higher. So that's because the box is bigger, is wider. And from the larynx, air will go to the trachea. Okay, so going back to the original order, the spectra, we've got nasal cavity, pharynx, then the epiglottis, then moving downward, we get into the larynx, which is this tiny part. Larynx is very small, it's just this part that produces the sound. That is the larynx, this part. And then we've got this tube that is the trachea. The trachea will divide into two bronchi. You've got bronchus here because it's singular, plural is bronchi, and these bronchi divide into bronchioli, which is the plural for bronchiole. The difference is whether they have cartilage or they don't. And at the end of the bronchioli, we're going to find these alveoli that we've got here. So the lungs, in fact, contain part of the bronchi, bronchioli, and alveoli. They are all included in this lung. Okay? Any doubt on these names? Do they sound familiar for you? I guess they do, because it's something that you see in primary school. You probably haven't seen these pictures before, like the vocal cords, probably haven't seen it before, but the way they work, I'm sure that they have explained it before to you. So what is the larynx? Is this cartilaginous structure, is hard, okay, is cartilaginous, and it produces it includes the vocal cords. So the mission is protect this place in which sound is produced. That's why is this hard cartilaginous structure here. That is the larynx. The reason why we give a different name is because the number of layers is different and the appearance is also different. Larynx, very small, and then this long trachea. Well, trachea is made up of these cartilaginous rings. In fact, if you touch it, you can notice different cartilaginous rings sometimes. Okay, so these cartilaginous rings, one, another one, and another one, and another one, they are not perfect rings. They are not all of them covered by cartilage. But if you could cut the trachea, we're going to do it with an animal, but we'll do it later in March. If you could cut the trachea of a mammal, what you are going to see is that on the back, this is the frontal part of the ring and is continuous, you can notice it, but on the back, there's no cartilage. There's an elastic tissue. What's the mission of this elastic tissue? Well, if you remember, this trachea on the back had the esophagus, very close. So this esophagus, when you were eating something very big, the esophagus must dilate. In order to have enough room, para tener sitio, in order to have enough room for the esophagus to dilate, this back part of the trachea is not going to be rigid, but it's a little bit elastic. It's only this elastic in this first part where the esophagus goes very close to the trachea. Then they separate because the esophagus will go to the stomach, so it's a little bit to your left part, and the trachea moves downward. So at the beginning, these first cartilaginous rings have what we call a C-shaped. Tienen forma de C, C-shaped. Okay, so that's something important that we've got about the trachea. If you go to page number 44 in your book, you've got that the trachea is a short, flexible tube formed by C-shaped cartilage rings. C-shaped means that they have the shape of a C, and the reason is that this is rigid, but this is elastic in order to let this esophagus dilate in case it needs to dilate. Okay, the esophagus is here. When you eat something very big, you need to dilate it. If this was a rigid tube, you couldn't do it. But because it's elastic, okay, it's going to be like that. Well, something like that is what happens there. And you've got there that air travels from the larynx to the bronchi inside this tube. Well, you also have that this tube inside contains more hair structures with mucus that are going to retain dust or dirtiness. In case you've got any dust, any dirtiness, or even droplets of water, what happens if you've got either dust or droplets of water in your trachea? What are you going to do? In case you've got something strange in your trachea, you're going to start coughing, okay, in order to send them out. So you can voluntary or maybe sometimes involuntary push air, move air very quickly outside. You're going to do that thanks to a mechanism in your respiratory system. You're going to push the diaphragm and send everything strange out. Remember, in first aids, that's what you're doing. When something strange is in the trachea, you want to push it out, send it out using the air in your lungs. Okay, well, so from this trachea, C-shaped rings, air moves to the bronchus, bronchi if it's plural, bronchioli when it gets smaller, narrower. The mission is exactly the same. But do you think they also have this C shape? No, they don't. The cartilage is circular now because there's no esophagus here that needs to be skipped. Okay. And then the final part that we're going to see today, just one more thing. And this picture is representing the larynx, the trachea, bronchi, both in yellow and red. Bronchioli would be this last part. And at the end, we've got the alveoli. But I was going to tell you that there's a physical evidence of a difference between two lungs. Do you see any physical difference, any difference in their physical appearance between the right lung and the left lung? Can anyone see any difference between them two? This right lung, remember it's right because if the person is facing at you, that is the right part. We always represent it like that, someone facing at you. So do you see any difference between this right and the left? Right. Okay. The one on the left, which is this one, but is the right lung, Ojo que esto es justo al revés, okay? The one on the left, that is the right lung, because this person is facing at me, that would be the face of a person. This person is facing at me, so the right lung is bigger than this one. What organ do I have here in this empty space? What is the name of the organ that I've got in this empty space? This left lung is smaller because it's leaving some room for your heart, okay? So there we've got the heart. This lung, the left lung, is smaller. But apart from being smaller, we see 1, 2, and 3 lobes. In Spanish, lóbulos. We see 1, 2, and 3 lobes in this lung, and there's only 2 lobes on this lung. So it is different in the size, but it is also different in the number of lobes. Well, having lobes could be very useful in specific cases. For example, if you've got an illness like tuberculosis or a lung cancer, if the illness is only affecting one of these lobes, you can just remove it. And the person could have a normal life with just these lobes. Well, of course, if cancer is affecting this big lobe, it's going to be a bigger problem. But if it's only affecting one tiny lobe, you could survive with no problem, just removing this lobe. Okay? Bueno, we've got 2 minutes to finish the class. So right now what we're going to see is we're going to have a look at the activities, because I'm not sure whether we correct everything. So whether I have to send you more homework, ask you to do more homework. This activity, que era la que me preguntaba principalmente, this activity, ¿dónde estamos? The one on the chicken sandwich, have you done it? Activity number 28. Vaya, ahora nos veo. Un momentito que nos veo. Have we done activity number 28? No, we haven't. Okay, so because it's a longer one, quite a long one, you're going to do for homework activity number 28, that is based on digestive system, and then from this respiratory system, the only thing that you're going to do is activity number 41. Okay, so 28 and 41, that's your homework. 28 and 41. Bueno, 28 and okay. If you get no more doubts, I'll see you tomorrow.